I'm from Infosys. I'm going to talk about a solution that we did for one of our client, using Apache Spark. So the use case here is about regulatory reporting of asset trading. So what is a regulatory report? So basically, so there is a regulatory requirement when you execute a trade. The end customer who executed the trade is supposed to receive the report about the successful execution of the trade. And it goes through several business validations to find if it's a valid trade. And if it's a valid trade, then they are supposed to get the report within a set time frame. So what are the challenges that, that we faced or our client was facing? So one of the major hurdles was that, okay, you have a strict window within which the report has to reach the end customer. And there is a frequent change in the regulations, and then you don't have a luxury of time to actually, to meet the deadline within which you have to meet the new regulations. And the other thing is the transaction volumes are quite high, and if you're a global company, then you would have a different set of regulation to simultaneously that you have to adhere to depending on the location where you are executing the trade. So to give a deep dive into the case study, so I already told you about what the regulatory report that we are at that time talking about. But most of these the reports, they basically go through four main things. That is, you have a transformation process, you have a enrichment process, you have a deduplication, and and then there are a set of business rules which actually validates whether whether the trade is valid or not. So this is a process flow diagram. So you have this asset trade coming in continuously. You apply some transformation based on the transformation rules that you have. Once you have the transform data, you do some enrichment. So what I mean by enrichment is that you have a master data and you join with whatever the log or trading logs that you receive. You create a new set of data, and then you apply. Then you apply business rules on top of that. You do deduplication of the data, and finally you have an end report that needs to be sent out to the customer. So at the core of it, this is the architecture that we followed. So we didn't really want to disrupt the upstream. So we just let however the system was as is. So these trading logs were coming into Oracle database. So we hooked up our solution to this Oracle database. So you have a scoop-based solution to actually bring in the data to HDFS. We use Spark to do all sorts of the enrichment process that I was talking about, the deduplication, run all the business validation, and then finally you have in the form of report, so that you can connect either your BI tools or any JDBC based application to actually read the report and then finally send down the report to the customer. So this is the statistics that we have. That is, we have around 1.12 million records that we could ingest. So we had the overall data volume, that is the history record against which we had to run the deduplication. That was around 500 million, and the execution time for generating the end report was around 35 seconds. Now contrast this with what was already in there. So there was this the time window that was set for this particular location was 15 minutes within which the report has to reach the end customer, and oftentimes they used to miss the deadline. And so you had a 15 minutes window, and we used to miss the deadline. But with the Apache Spark, we were able to reduce the time to 35 seconds. So that we believe that was a great achievement that Apache Spark provided us. I'm going to skip to the next slide. So what we did is Infosys built a solution called Infosys Information Platform. So we have Spark as one of our main computation engine, which does all the in-memory computing. We make use of Spark streaming, MLlib for our machine learning. We also make use of Hive and Spark SQL. We have HDFS as the data store. And then we have, so this is an open source stack. Additionally, we have our proprietary components on top of that. To give a little more details about IIP, so you can hook up pretty much basically to any kind of data sources that you have. So it could be an RDBMS based or FTP based or an SFTP based. It could be a streaming thing like a Kafka or Flume or whatever. And then you bring in your data into the data lake. You have The Spark is the one which provides us this extreme fast, in-memory computing. You can also resort back to MapReduce if you want, but yeah, Spark makes life easy. And then we built on our security layer, and we also made a couple of enhancements to Spark, which we have some, which would like to contribute it back to open source, which gives you, some level of authorization on the reports that you have generated, and also it also gives you an option to register a view in a runtime, which can be consumed by the BI tools. So I'll skip on to the demo. Yeah, how do I get to the desktop?
Let's switch it back to a mirrored mode for you.
Okay.
Just take a second.
Yeah, this is good. Yeah, so this is how we implemented the use case, using Infosys information platform. So here I'm ingesting data from Oracle data source. So you can create a data source, and then finally you can view all the tables that are below, that is part of the schema. You ingest them. Here I've already ingested the table, so these are the set of tables that I ingested. I brought in. So right now I'm submitting this as a job. So once this is done, now I have the entire data set sitting in HDFS. Right. So these are the set of tables that we just ingested, and the records are continuously coming at a minute basis. And so we have already all the tables out there. Now the next step is to actually express all these the business rules and stuff in form of a Spark SQL. So we were able to do joins between the data enrichment that I was talking about, between the master table and the log information that is coming in, and the deduplication that I was talking about. So you remove all the duplicates from your incoming data, and so this is the final report. So now I have been able, I did all my derived attributes, I created the final view, and now I'm generating the final report. The final report is then saved as a Parquet file, so that it's always there for consumption. And the beauty of the solution was that we could take this Parquet file and then register as a table, and then it is already available as a BI tool. So if you see, there is no use. We haven't used a Hive or anything here. So we didn't we didn't organize the data as a Hive table, but instead we just put it as a flat file in HDFS, and it's available, for all the tools to consume. So you get just a preview of it, and so this is a brief demo of how you can connect your Tableau to the data source to preview your data or draw any more insights that you want to do. Yeah, so say everything in Tableau. Yeah, so this is the use case that I wanted to talk about, the way how we used Apache Spark to solve an existing business problem, which was costing a lot, and we were quickly able to. I mean, the whole thing was put together probably in a matter of a week, beat the time of 15 minutes what it used to take, and now it was like just 35 seconds.
Awesome. So we have time for 2 questions. You can clap if you want. All right.